Right, so we can actually pull more information from carbon NMRs if we run different types of NMR experiments. And so one example of this is these Dept experiments. This stands for distortion enhancement by polarization transfer. Yeah, whatever that means. Not going to go into depth there. The useful piece of information is this tells us how many hydrogens are on each carbon. Right? Is this a CH? Is it a CH2? Or is it a CH3? Right? Not going to be a CH4 because then that's just methane gas. And so write our options again: CH3, CH2, CH, or just a C with no hydrogens on it. And so the type of carbon NMR that we looked at previously is what's known as broadband decoupled. And so all carbons will show up as a peak there, right? All carbons will be visible. And then you can do other types of experiments such as Dept 90. We won't go into the details there, but basically when you do Dept 90, CH3s will no longer show up at all. CH2s will no longer show up. CHs will show up as a peak, and regular carbons will not, right? So you can see from your Dept 90, every peak is corresponding to a CH peak. And then finally, we have Dept 135. In Dept 135, your CH3 peaks show up. Your CH2 peaks show up, but they're upside down. They point down. So I'll show you what I mean in a minute here. Your CH peaks also point up, and then your Cs don't show up at all, right? And so by looking at these three NMRs, you can figure out what kind of carbon you have from this experiment, right? So let's take a look at an example. So obviously these are already labeled for us, but we're going to pretend that these are not labeled. And so our compound looks something like this. And let's go ahead just through them one by one, and we'll go through them. Pay no attention to the fact that it tells you that it's a CH right there. So we see that it's pointing up at the regular broadband decoupled, pointing up at the Dept 90 and up at the Dept 135. If we take a look at the things that are only pointing up, that's got to be a CH, right? So in this case, this is a CH. And in our case, in this molecule, there's only one thing or one carbon that has one hydrogen on it. So it's got to be this carbon right here. Next up, we have something that's in the C13 NMR, which everything is, disappears in the Dept 90 and is pointing down in the Dept 135, right? You see how this peak is pointing down? And so if we look which one fits there, that will be a CH2. Sorry about that, my tablet's not feeling it today. And the only CH2, oops, we actually have two CH2s right here, right? We have two CH2s. And so how do we decide which one's which? Well, then we take a look at the chemical shift, right? This one's at 120, indicating that it's part of a carbon-carbon double bond. And so it must be this carbon right here. Next up, we've got this CH2. And it, or my bad, the CH, and it displays the same thing as the purple one, right? And we can't see this, right? So it displays the exact same thing. So it's also a CH2. We only have one other CH2, and so it's gotta be right there. Next up, we see this tiny peak over here, peak D, and we see that it shows up in the broadband decoupled, but we don't see it in either one of these other two. And so if we look at which one only shows up at the broadband decoupled, that's got to be our quaternary carbon, right? No hydrogens attached there. Let's see, what color did I pick there? Blue, I think green is up next, right? So this green one is corresponding to this one. And then finally, we have this final peak, which is pointing or is in the broadband decoupled, which everything is, and is not in Dept 90 and is pointing up at Dept 135. And so if we think about that, that must be a CH3 peak. And so that'll correspond to all three of these carbons. So that's one way to convey this information. Sometimes you'll get all three spectra and be asked, what's a CH2, what's a CH3, that kind of thing. The other way they might tell you is that they just might straight up tell you what it is. So they might only show you this top spectra, just the carbon 13 decoupled spectra. And what they do here is, since this is a CH, we say that this is a D or a doublet. Right, so we're pretending that it's being split by whatever protons are attached to it. So if it's a CH, it's only got one proton attached to it. And so it's N+1, it'll be split into a doublet, right? This right here was a CH2. And so we would call this then a triplet, or you'll just see a little T. Right, this is also a CH2, so that'll also be a triplet. This quaternary carbon right here will be a singlet, or you'll just see a little S. And then finally, this CH3 will give a Q for quartet. Honestly, we won't use these advanced carbon NMRs too much. For most of our simple compounds, you just want to focus on the symmetry that you get from the carbon NMR, the location of the peaks, and then you can rely mostly on proton NMR for the fine details.